In this video, I would like to present how you can program with domain-specific aspect language that was developed using the awesome framework and Spoofax in Eclipse as if it was aspect-J. I will not show you here how to implement a language. I will just show the steps you will need to follow in order to use an already implemented language. So I'm using Eclipse and I installed aspect-J development tools version 2.2.4, which includes aspect-J compiler 1.8.5. Note that this version has not been released yet, so you'll need to use the development version. And I also installed Spoofax Runtime. Since version 1.4 of Spoofax, you can install only the relevant part that is needed when you are programming with a language. So, okay, now I will create an aspect-J project, which is named Cool Demo. For this example, I will use the Cool language, which is a domain-specific aspect language for thread synchronization. And I will use the bounded stack example. You see, all the code of Awesome is open source and is available on our GitHub page of the Open University. There are three relevant repositories: the AOP Awesome repository, a fork of the aspect-J repositories in Eclipse, and the AOP Awesome Frontends repository that we will get to it a bit later. In the AOP Awesome repository, we have the bounded stack example, which we'll use to test our implementation for Cool. So we will use this one. Okay, so we have it all in our project. As you can see, one of the files ends with the Cool extension. This file contains an aspect in the Cool language. In the Cool language, aspects are called coordinators, and they contain the information that one will need in order to synchronize his class. So, as you can see, Eclipse doesn't recognize this file. You don't see text highlighting, for example. To get the editing capabilities for Cool, we needed to generate a plugin for Eclipse for Cool. So, in the AOP Awesome Frontends repository, we have Spoofax project that allows us to generate Eclipse plugins for these extensions. Once you open these projects in Eclipse and compile them, you can generate the Eclipse plugin by using the export option, select deployable plugins and fragments, and I will generate the plugin in my home directory. So now I'll quit this instance of Eclipse and I'll copy the plugin that I just generated into the droppings folder in Eclipse. And I'll invoke Eclipse again. Now, using the plugin, I expect to get the editing capabilities such as text highlighting, error checking, and so on for code in the cool language. I'll open again the coordinator, and you see now Eclipse recognizes this file. We get the text highlighting for our code. Okay, so now this code is recognized as in Eclipse, but let's say that I will try to run this project, so I'll compile it. And I will run it. You see, we get that the stack is not synchronized, which means that the cool aspect didn't do anything to the stack. Now it makes sense because we were using Aspect.J as backend, which doesn't recognize cool coordinators. So to solve it, we will go into the AOP Awesome repository and we will compile it using Maven. While it's compiling, we will set in Eclipse in the content types, we will add cool coordinators as Aspect.J source files, so they will be passed to the backend as well. And I'll quit Eclipse for now. Once the compilation is completed, you need to invoke the cool compile script, which will produce jars for the cool language that can be used inside Eclipse. Once it's finished, you will see in the dist folder the produced jars. Note that I call them the way they appear in the current version of AJDT, of the Aspect.J development tools that I use. So I can just copy them into my folder in Eclipse, the plugins subfolder in Eclipse. And I'll invoke Eclipse again. Now that I replaced the backend part with jars that support cool, I will recompile the project. And now, when I run it, I'll get that the stack is synchronized. So that way, we can program with cool coordinators in Aspect.J projects in Eclipse, and the call coordinators act like regular Aspect.J aspects. In a different video, I will show how to develop a domain-specific aspect language using Awesome and Spoofax that can be used that way.